Welcome. The topic we'll be discussing in this lecture is antennas. So basically here we'll be discussing the different types of antenna. So, so antennas are something like a trans receiver. That is, it acts as a transmitter and also it acts as a receiver. It couples the electromagnetic energy to and from the space or to and from any wired communication channel like coaxial cable or any other conductor. The theoretical reference antenna is called as isotropic radiator. Theoretical reference antenna, it is called as isotropic radiator, which will radiate which will radiate pattern symmetric in all directions. Okay. Basically, this antenna will radiate symmetrically, it is equally in all direction. But this is not a real antenna. There is no such antenna exist which in the real world which which transmits symmetrically in all direction. Okay. So this is just a theoretical reference antenna, and it is not exist in reality. And this is how it is represented pictorially. That is, the particular antenna radiates symmetrically in all directions. So this is the first type of antenna that we are discussing. Actually, the real antennas have some directive effects. The real antennas, they don't transmit or radiate signals symmetrically in all direction. Rather, they are more focused to certain direction over other directions. So now we'll be discussing several real antennas that are available. So the next type of antennas that we'll be discussing is called as directive antennas. It's called as directive antennas. So one of the example for directive antenna is dipole. It's a simple real antenna. It's a dipole. It is called as dipole because it consists of uh, it consists of two separate conductors. It consists of two conductors of equal length which are separated by a feeding gap. Basically, this antenna, it consists of two conductors of equal length, and these conductors were separated by a feeding gap. Okay. And the length of this dipole antenna will be equal to the half of the wavelength of the signal that it is supposed to transmit. Okay. So its length will be generally equal to lambda by 2. If the length of this antenna is equal to the half of the wavelength of the signal that it's supposed to transmit, then it will provide the best performance. That is, it will transmit or it will radiate energy uh, in in the best possible way. If this antenna is mounted on a car, then its length can be lambda by 4. Generally, its length should be lambda by 2, that is wavelength, half of the wavelength. But if you are mounting this antenna on a car, then its length can be lambda by 4. This antenna is also called as Marconi antenna. Dipole antenna is also called as Marconi antenna. So how it radiates energy, the pattern in which it radiates energy is specified in different planes. So let us see that to a diagram. So it has basically uniform or omnidirectional radiation pattern in one plane. In one of the plane, that is in XZ plane, it has uniform or omnidirectional radiation pattern. But in the other two planes, in XY plane and YZ plane, it has a pattern, it has a radiation pattern which is similar to the numeric 8. Okay. So basically this type of radio, what it does in the sense, it just boosts the signal. It just boosts the signal. Okay. And the challenges about these antenna is that it may not work effectively in the areas where there are mountains, valleys, and buildings of there. So it can just boost the signal, and 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 it can overcome few environmental challenges. Okay, but it may not be effective where there are mountains, valleys, or buildings are present. So so this is how the dipole antenna looks like. You can see here its normal length will be lambda by 2, that is half of the wavelength. If it is mounted on a car, then its length can be lambda by 4, and these are its radiating pattern. So this is in XZ plane. In XZ plane, it radiates uniformly in all directions. It's omnidirectional. Whereas in YZ plane and XY plane, its radiation pattern is something similar to the numeric 8. So and and basically it what it does in the sense, it boosts the energy, and it can overcome few environmental challenges. But the drawback or the challenge with respect to this antenna is it may not work properly where there are mountains, valleys, and many buildings are present. This is about dipole antenna. The next type of antenna that we will be discussing is directional antenna. So the next type of antenna that we'll be discussing is directional antenna. So the problem with the dipole antenna is it cannot work properly with valleys, mountains, or buildings. Whereas this directional antenna, it can work. It can also work properly even if there is a valley or in between buildings. Also, it can work properly. And these antenna, it has it has fixed preferential transmission and reception direction. Okay. So it has fixed preferential transmission and reception direction. That is, they are focused to one particular direction for transmission, and maybe they are focused to some other direction for reception. Okay. Sometimes the transmission and reception may be focused in the same direction also. That's not a issue, but they are focused on one particular direction for transmission, and maybe on the same or another direction for reception, and by that they avoid interferences, uh, interferences. Okay. So this diagram shows the uh, shows how the radiation pattern of directional antenna looks like. So in YZ plane, it looks like omnidirectional, but in XZ plane and XY plane, you can see it is very much focused in one direction, and it is totally neglecting other directions. Okay, so these are called as directional antennas. And a good example for directional antenna is satellite dishes. Okay, so we have dish TV. So in dish TV, if you see, the dish is actually kept in such a way that it faces only one direction, right? One particular direction. So the opposite direction it totally ignores, right? Because the signal is going to come only from this direction, so it need not focus in other direction. So such antennas are called as directional antennas. Okay. So that's it about directional antenna. The next type of antennas that we'll be discussing is called as sectorized antenna. This sectorized antenna. So, so what is a sectorized antenna? Several directional antenna can be combined on a single pole. several directional antennas can be combined on a single pole. Such antennas are called as sectorized antennas. Okay. And in case of cellular communication, a cell can be sectored into 3 or 6 sectors. What is a cell? A cell represents the communication range of the base station. Cell represents the communication range of the base station. That is, the base station maximum to what extent it can communicate. This its communication, the communication range of the base station is called as cell. So cell can be divided into 3 or 6 sectors as shown in the below diagram. So why should we divide? By dividing it into sectors, the frequencies can be reused. So if the frequencies are reused, then it can support more customers. Okay. So such antennas are called as sectorized antenna. Fine. And the next type of antennas that we will be discussing is multi-element antenna arrays. Okay. So that's the next type of antenna that we'll be discussing, multi-element antenna arrays. With multi-element antenna arrays, two or more antennas are combined together. Two or more antennas are combined together to improve the reception. Because normally, when an electromagnetic signal is getting transmitted, they go through different types of distortions like reflection, refraction, all these things it happens. Okay, so one antenna may not receive everything perfectly. So if you keep more than one antenna, signals from different directions can be received, and finally they can be added up and some and useful information can be collected. So that is what this multi-element antenna array does. Two or more antennas are combined to improve the reception. Okay. So these antennas also support some diversity schemes. Okay, these they allow some diversity schemes. So there is one such scheme is switched diversity or selection diversity. Switched diversity or selection diversity, which means that the receiver uses the antenna element with the largest output. Say here there are two antennas. Say there are two antennas. For example, if you see this particular diagram, uh, there are two antennas are there. Okay, and these two antennas are connected to some device, right? Maybe this antenna may have high reception power. Okay, or this antenna's output may be high, and this antenna's output may not be that high. Then your receiver may always prefer to receive from this particular antenna. That is what it says. Switched or selection diversity means receiver uses the antenna element with largest output. Okay. Or say for example, in the morning time, the data received through this antenna, the output is high. But in the evening time, the this antenna produces high output. So in the morning time, your device will receive from this antenna, and in the evening time, the device will receive from this antenna. So that concept is called as switched or selection diversity. So whichever the antenna provides a better output, the receiver can receive from that particular antenna. Okay. So here you can see there are two antennas of length lambda by 4. They are combined together to form a multi-element antenna arrays. And these two antennas are separated by a distance lambda by 2. Whereas in this diagram, there are three antennas, each of length lambda by 2, and all these three antennas are separated by a distance of lambda by 2. Okay. So these type of antennas are called as multi-element antenna arrays. The next type of antennas that we'll be discussing is called as smart antennas. What is a smart antenna? So it's a quite advanced solution. Basically, smart antenna is also an multi antenna elements. Okay. Basically, smart antennas also multi antenna elements, but they also include signal processing. They also performs signal processing, in order to optimize the radiation and reception pattern. Okay. So, so, so as they perform signal processing to optimize radiation and reception pattern, these antennas are called as smart antennas. Okay. And these antennas can adapt to changes. These antennas can adapt to changes depending on the reception power, transmission conditions, and signal propagation effects. Okay. So depending on the reception power, if the reception power is low, okay, then the antenna can adopt to receive even the signal with low power. Okay. So like that, depending on different conditions, the antenna can adopt itself. Right. So such antennas are called as smart antennas. Right. That's it about the topic antennas. So we have discussed around 4 or 5 types of antennas. So the first type of antenna that we have discussed is isotropic radiator, which is a theoretical reference antenna which radiates equally in all direction, but no such antenna exists in real time. And then we have discussed the dipole antenna, dipole antenna, uh, which uh, which which exhibits uniform omnidirectional radiation pattern in one plane, and in other two planes its radiation pattern is something like number 8. And then we have discussed the next type of antenna, which is a directional antenna. The dipole cannot be used in mountains, valleys, or in between buildings, whereas directional antennas can be used in between buildings also, and they are preferential to one particular direction for transmission and reception. Then we have discussed sectorized antennas, and then we have discussed multi-element antenna arrays, and finally we have discussed smart antennas. Right? So let us stop here. Thank you.